Hi students, today we're looking at the Algebraic Expressions lesson, and your learning target is I can add, subtract, factor, and multiply algebraic expressions. Before we move on, please take a moment and write your learning target in your planner for today. And once you have that written, please pay attention to the supplies that you will need for this lesson. You will need a pencil and two different color highlighters or markers or something along those lines. You just need some sort of utensil. It's going to give you two colors. Okay, so your first example that we're just going to jump into is this word problem. It says that Jill and Kelly work as consultants and get paid per project. Jill is paid a project fee of $25 plus $10 per hour. So let's go ahead and assign a color to Jill. I'm going to use red for Jill. And she gets paid a project fee of $25 plus $10 an hour. So that's important. And then let's read about Kelly. And for Kelly, I'm going to do this blue. So Kelly is paid a project fee of $18 plus $14 an hour. And the question is asking us to write an expression to represent how much a company will pay to hire both consultants for a project. That's our keyword right there, both. All right, so it broke it down into three sections for us. How much for Jill, how much for Kelly, and how much for them both together. So Jill for me is red. You guys can use whatever color you are using. And Jill works $25 plus $10 an hour. Well, based on reading this problem, do we know how many hours Jill works? No, we don't. So we're going to use some sort of variable to represent how many hours that she works. So we're going to say that Jill she gets $25 no matter what, plus $10 per hour. Per means multiplied by, so per hour. And you can either write it like this or use some sort of other variable that you want. So I did 25 plus 10x is how much Jill is going to be paid. Take a moment and see if you can figure out how to write Kelly's, how much Kelly would be paid based off of the information that we put in blue here. So Kelly would get $18 for each project plus $14 an hour. And we don't know how many hours, so we're still using a variable. And then what it's asking, oh, and I forgot my dollar sign here. What it's asking us is how much for them each together. How much is it going to cost to have both consultants for a project? So we need to figure out how much Jill would charge, or how much it's going to cost for Jill plus the cost of Kelly. So go ahead and see if you can figure out how we're going to write these expressions using the color code that I just put on the screen to figure out how we're going to find out how much it's going to cost together. See if you can pause the video and see if you can figure that out. And if you took some time to work on that, you should have written Jill's cost here, 25 plus 10x, plus Kelly's cost on the next line, which would be the 18 plus 14x. And then you should have taken a minute to look at that expression and ask yourself, can I make this any simpler? Can I simplify this equation? Anytime you're working with algebraic expressions, you're going to have to ask yourself, can I simplify? So I'm just going to write a simplify right here with a question mark after it. So that way I always remember to ask myself, can I simplify this? Well, I can. So we look for like terms. Remember those words, like terms. And let's just look for some. We've got 25 and 18. So we can do 25 plus 18. Oops, that's 8. And then plus 10x and 14x. Those are like terms. So plus 10x plus 14x. And what does that simplify to? Oops, that's an x. Well, 25 plus 18 is 43. And 10x plus 14x is 24x. So this formula or this expression right here in purple is how much it would cost to hire both consultants for the project. So 43 plus 24x, or you can switch it and do 24x plus 43. Both answers are correct. Okay, so you have a couple of additional questions to answer about Jill and Kelly on questions 1 and 2 for your practice. And please note that question 2 is question 1B on page 59 in your book. And I'd like you to complete it on the back of this paper so I can check that in class. All right. Now we are going to look at factoring. And factoring in dealing with algebraic expressions is very similar to when we factored just plain numbers. So just as a quick refresher, remember that you can take, let's say, the number 15, and you can break it down into 3 times 5. Oops, that's a 5. And you can also break it down, you can do 15 as what else? 15 times 1. There, I think those are the only 2 ways that I can think of that you can multiply 2 numbers to get 15. So this is the definition of factoring. It says to factor a number is to write a number or algebraic expression as a product. Remember, product just means multiply. And then I put here Mrs. Baker's hint is to undo the rainbow, and I will show you what I mean when we're dealing with this first problem over here. So the problem tells us to factor 4x plus 8. Now typically, up until now, you've only been asked to factor a number, but now we've got numbers and variables or some sort of expression that we're working with. So let's go ahead and look at this. Remember, the key to factoring is to find one number that goes into both sets of numbers. So in this one, we have a 4 and we have an 8. So we need to find a one number that goes into both 4 and 8. Take a moment and think about it. See if you can figure out what that might be. Well, for me, I know that 4 can go into 4 and 4 can go into 8. So I'm going to use 4. And we're first going to look at it algebraically because I think that's a little bit easier. Your book looks at algebra tiles first, but I preferred the algebraic process. So we've got 4x plus 8, and I know that 4 goes into both. So basically, I am creating a distributive property problem. I'm undoing the rainbow. So here I'm going to put my 4 on the outside of parentheses, and then I'm going to take out a 4 from this. So taking out a 4 from 4x, well, 4x divided by 4 is just x. And then 8 divided by 4 is just 2. So I've got x, and it's a positive, so x plus 2. So do you notice, now that we're done, because that, believe it or not, is our answer, do you notice how we basically created a distributive property problem? Now we have 4 times x is 4x, and 4 times 2 is 8. So the final answer is 4x plus 8 if you're checking your answer. But when it's telling you to factor it, it's telling you to put it in this form. So 4 parentheses x plus 2 is actually our final answer. But you can check it by doing the distributive property and seeing if you get 4x plus 8. All right, so before we go into algebra tiles, let me show you one more with 12x plus 9 down here. And for this one, we're going to look again for a number that goes into both 12 and 9. So any number that goes into both 12 and 9. And for me, I think that it's going to be 3. So I'm going to put a 3 and then a parentheses. And 12 divided by 3 is 4. So I'm going to do 4x here. And 9 divided by 3 is 3. So I'm going to do 4x plus 3. This is my final answer. Okay? So if you're going to use algebra tiles, it's a little bit, in my mind, it's a little bit more complicated, but it is important to see why this works. So let me show you. This is when you'll need 2 colors. So we're going to use algebra tiles to represent 4x plus 8 and how to factor it. And I'm going to use this light blue color to represent my x's. So this is going to be my x, this blue rectangle. And then I'm going to use, I'm going to use orange for my single digits. So this will be my single digits. Okay? You can use whichever two colors you prefer. Those are mine. And what we're going to do is look at this. So we've got 4x plus 8. So we've got 4 of these blue tiles. So I'm going to do it right here. And I'm actually just going to draw a box that I'm going to work in. So I've got 4 x's. So I need 4 of those blue rectangles. You can draw this on your paper too. And then I need 8 of those single squares because I have 8 right here, plus 8. And I need to distribute those 8 amongst these 4. So I need to do 1 here, that's 2, 3, 4, 5, 6, 7, 8. And then all it's asking me for is to look at one of these columns right here. And I've got 1x, so I've got 1 blue bar and 2 orange bars. So 1 blue bar and 2 of the orange squares. And then how many columns do I have total? Well, I have 4 of them. So in red, I'm going to put that I have 4. So basically, I'm using 4 times of these blues, and 4 times these orange is going to get me 4x plus 8. And so I'm going to have 4, my final answer would be 4 parentheses x plus 2. And I only have 1x because I have 1 blue bar here, and I have the number 2 because I had 2 units right here, or 2 orange blocks right here. So my final answer is 4 parentheses x plus 2, just like the one I got here. It's up to you which one you would prefer. I prefer just looking at it algebraically. I do not like drawing algebra tiles. You do not need to know how to draw algebra tiles for any of the tests that we have coming up. You can just show me how to do it algebraically. All right, and then for your practice on numbers 3, 4, and 5, you can just factor these out. Remember, you are trying to create something that looks like you'll need to do the distributive property. You have to undo this rainbow. So here's the result of the rainbow. You have to undo it and add parentheses to this expression. Okay, so make sure you look at 3, 4, and 5 and complete those before you come to class. And then don't forget that you have a second video to watch today also. So please make sure you get that one done as well.